It takes up to 4,000 years for a tire to decompose naturally, which has long made it one of the most problematic and feared types of waste on the planet. For decades, it was considered too polluting, too bulky, and too dangerous, to the point of being rejected by almost all recycling facilities. Yet today, this same waste is actively sought after by engineers and civil engineering professionals, to the point of being called the black gold of modern road construction. In this documentary, we follow the complete and spectacular rebirth of a single tire. From the precise moment it is discarded, through the high-precision grinding and screening processes that transform it into ultra-fine rubber granules, to its fusion with heated bitumen to create a road of exceptional durability. A process that opens up a whole new life cycle for a material once considered useless. If you want to discover the entire process behind the transformation of used tires, stay with us, because this story will forever change your perspective on these everyday objects. Every year, more than 1.5 billion tires are discarded worldwide. This volume is so immense that, seen from the air, many storage sites resemble vast black oceans stretching to the horizon. Left in the environment, tires barely degrade and continuously release harmful chemicals, turning parts of the United States, Europe, and the Middle East into major pollution hotspots. Yet, this colossal mass of waste has led to an unexpected turning point. Rubberized asphalt, now a multi-billion-dollar industry, makes it possible to recycle up to 10,000 tires for just 1 kilometer of road. In addition to valorizing waste, it makes roads more resistant, more flexible against cracks, and reduces traffic noise by approximately 6 decibels. Once a symbol of pollution, the tire is now emerging as one of the most promising sustainable building materials of the 21st century. Every day, in the quiet workings of modern cities, thousands of tires reach the end of their lifespan in garages, maintenance centers, specialized landfills, and large-scale replacement platforms. The majority of these tires have already exceeded safety limits in terms of wear, elasticity, and load-bearing capacity. When discarded in nature, a single tire can persist for decades without decomposing, slowly releasing organic compounds and heavy metals, becoming a long-term source of soil and groundwater contamination. In many countries, a used tire is worth only a few cents when sold as scrap. However, from the recycling industry's perspective, it represents a veritable urban resource. Each tire contains a complex mixture of natural rubber, synthetic rubber, steel reinforcements, textile fibers, and chemical additives, all high-value materials that can be recovered and reused when properly processed. Collection is generally organized along fixed routes. Specialized trucks, equipped with reinforced platforms and secure tie-down systems, collect tires from multiple sites to optimize transport volumes. This method reduces logistics costs and avoids open-air storage, where tires can retain rainwater and become breeding grounds for disease-carrying insects. The recycling process begins with the management of the steel reinforcement embedded in the tire. This part allows the tire to remain securely attached to the rim at high speeds. But in a recycling line, this steel ring becomes a major obstacle. If it is not removed upstream, it can damage the blades, break the drive shafts, and block the entire shredding line. In the first stage, the tire is fed into a bead breaker. An extremely powerful hydraulic system forces its way into the tire and tears off the steel bead in a matter of seconds. The force exerted is so great that the rubber casing twists and deforms violently during the operation. On average, a heavy-duty truck tire yields approximately 2 kilograms of high-quality carbon steel. Once separated, the steel fibers are compressed, bundled, and sent to steel mills, where they begin a whole new life cycle. The remaining carcass then becomes much more flexible and ready for coarse grinding. Before any mechanical processing, the tires undergo high-pressure washing to remove mud, oil residue, and embedded gravel. This often underestimated step is nevertheless essential to preserving the longevity and stability of the entire production line. During the primary shredding stage, the whole tires are cut by slowly rotating alloy steel blades with very high torque. This method limits the temperature increase, preventing the rubber from softening or sticking to the blades, while simultaneously cutting it into fragments several centimeters in size. These pieces then undergo secondary grinding, where their size is further reduced. The internal metal reinforcements gradually fracture and are extracted by powerful magnetic systems, transforming the recovered steel into a fully recyclable material stream. The final product then becomes a rubber granule with controlled particle size. At this stage, the tire has completely lost its original shape. It is now a raw material ready for use in construction, transportation, and industry. At the end of the line, a screening system classifies the particles. Those that do not meet the required dimensions are returned to the crusher. The fraction between 0.5 and 2 mm is the most sought after, as it is ideal for the production of rubberized asphalt. However, these granules still contain moisture, fine dust, and traces of impurities. These elements impair adhesion with the hot bitumen. Therefore, the rubber must be dried and heated before mixing. The granules enter a rotating inclined drum where hot air circulates at temperatures between 90 and 125 degrees Celsius, gradually removing any remaining water. Once preheated, the rubber is ready for the key step, mixing with bitumen. The bitumen is heated separately in tanks until it reaches a stable temperature, typically between 160 and 190 degrees Celsius. The rubber granules are then gradually incorporated, in proportions ranging from 10 to 20% of the total binder mass, depending on the required technical specifications. Inside the mixer, heat-resistant blades create a continuous vortex, forcing the rubber and bitumen to interact for 30 to 60 minutes. The rubber particles swell as they absorb the light oils from the bitumen, increasing the viscosity of the mixture and significantly improving its elasticity and crack resistance. Once homogeneous, the rubberized asphalt is loaded into trucks with preheated dump bodies to prevent premature cooling. On site, the mixture is spread by a paver to a precisely controlled thickness, then compacted by vibrating and pneumatic rollers before the temperature drops below the critical threshold. In just a few hours, the road is ready to be reopened to traffic. Over time, even its roads eventually wear down. But asphalt, including that made from recycled tires, can itself be recycled almost indefinitely. Old roads thus become the raw material for future infrastructure, placing this material within a true circular economy. Rubberized asphalt perfectly illustrates humanity's ability to transform an environmental problem into a concrete solution. Tires once considered worthless are now being used to create more durable, quieter, and more environmentally friendly roads. The value of a material lies not in its appearance, but in how we choose to use it. And now, do you think this type of recycling is a silent revolution or a solution still too marginal to truly change things? Share your thoughts in the comments. And if you enjoyed this documentary, don't forget to like, subscribe, and turn on notifications so you don't miss any of our content.